So to differential equations, we have the variable separable method. So what do you mean by the variable separable method? Basically, we're going to have two different variables and integrate each separately. So how? Take a look at this example, dy dx equals to x over y. So there's no directly integrable forms, right? You cannot integrate y with respect to x. So what do? We can just separate it, we cross multiply, so we have y on the left and x dx on the right to give us integrating y dy and integrating x dx. You cannot just write down y dy and x dx only. Integrating both sides, you get y squared over 2 plus c and x squared over 2 plus d. Now, what we do is let's say we want to make y the subject, we get y squared over 2 equals to x squared over 2 plus d minus c. D and c are constant, so we can just represent it as a singular constant f. And because of that, we actually can just write just one constant only. There's no need to write two different arbitrary constants by writing just y squared over 2 equals to x squared over 2 plus c. So let's just take a look at how this works, alright? So let's look at the proof. So if a function of y equals to the function of g, and where fy equals to gx, if we dx on both sides, so differentiate both sides with respect to x, on the right it's just very simple, right? Dx of gx is simply g prime, right? That's just basic differentiation. On the left though, again, you'll get f prime y. However, you must multiply by the derivative dy dx, alright? So what happens is that we simplify dy dx equals to g prime x over f prime y, and this is how the variable separable works, okay? So let's take a look at another example. Now that we know why this actually works. Let's say we have dy dx equals to, let's have x squared plus 2 over ln y, okay? So obviously there's no directly integrable forms, right? So we have to do variable separable method. We have integrating ln y dy equals to integrating x squared plus 2 dx. It's just simply a simple cross multiplication. So again, whatever you learned in integration applies here. So here you cannot integrate ln y directly. We must use the integration by parts, where we will integrate one and then differentiate the other. So integrate 1 to give us y, and then now we differentiate ln y to give us 1 over y. 1 over y times y is 1. Then on the right is just simple algebraic integration. So increase the power by 1, divide by the new power to get x cubed over 3 plus 2x. Then we continue solving y ln y minus y equals to x cubed over 3 plus 2x plus c. So yeah, there we have it, the variable separable method, where we have the general proof here in the center of the screen. And yeah, a pretty easy method.